In this example, we're going to take a look at data about the overhead width and weight of seals. And we want to test to see if there is sufficient evidence to conclude that there is a linear correlation between these two variables. So to do that, the first thing that we need to do is we need to create a scatter plot to check to see if our data even appears linear. Because if the scatter plot shows that the data does not appear linear, then it does not make sense for us to continue on um, and test for a linear correlation. So below here, you see that I've already created a scatter plot in my calculator. So what I did was I typed in the overhead width. I called this my x variable. Oops, let me use a pen, not a highlighter. Okay, so that's my x variable and weight is my y variable. And I typed my overhead width into list 5, so L5, and the weight into list 6, so L6. And the reason why I put it into those lists is because I have data for examples 1 and 2 saved in the other list, list 1 all the way up to list 4. Okay, so after I created the scatter plot, hopefully you can see below that the data, it does appear to have a positive linear trend, but as we can see here, it looks like there is some variation in the y values, so it doesn't look like it's perfectly linear, and that linear relationship, it's kind of hard to tell if it's strong or a weak relationship. So to figure out if it really is linear and if that relationship is a strong or a weak one, we need to do a hypothesis test. So let's begin the hypothesis test. So to do the hypothesis test, the first thing that we need to do is state our hypotheses. So the null hypothesis is always that rho is equal to 0, which means that there is no linear correlation between our two variables. And our alternative then is that rho is not equal to 0, which implies that there is a linear correlation between the two variables. Okay. All right, so let's see here. Notice that in this problem, it doesn't give us a significance level. So if it doesn't give us a significance level, you can test using 0.05 or 0.01. These are the common significance levels that are used in hypothesis testing. So I'm going to go ahead and use my calculator here and perform the linreg t-test. So you're going to use linreg t-test, right? But before you can do linreg t-test, you have to make sure that you type your data into a list. So again, I have mine saved in list 5 and list 6, okay? So let me tab over to the next slide. In the first slide, and then we will analyze the results. So our test statistic was 5.986. Our p-value was 0.0039. The correlation coefficient is 0.9485. And the regression line, we got negative 156.88 plus 40.18x. So this regression model gives us predicted weights of these seals, right, when we substitute in various overhead widths. Okay. All right, so I'm going to use the critical value method here and the p-value method. So I'll show you both methods to make a conclusion about the null hypothesis. So if we're using the critical value method, I'm going to use the table A3, which you can find in the appendix, okay, to get the critical values. And I'll show you what those critical values are for an alpha level of 0.05 and an alpha level of 0.01. So to use that table, you need to know what your sample size is. So in this particular problem, we have 1, 2, 3, 4, 5, 6. So n is 6. All right, going to the table when n is 6 and at a significance level of 0.05, our critical value is plus or minus 0.811. At a significance level of 0.01 and sample size n equals 6, the critical values are plus and minus 0.9 0.917. So let me draw the number line here. Our correlation coefficient is always a number between -1 and +1 with 0 in the center. So I'm going to use red here to mark the critical value for significance level of 0.05. So that's going to be, let's see here. Let's say that that is approximately -0.811, and this is +0.811. So this red shaded region on the right and this red shaded region on the left represents our critical region. So if our R value falls between +0.811 and +1, or -1 and -0.811, then we would reject the null hypothesis. But I'll use green here to mark our correlation coefficient. Since our correlation coefficient is 0.9485, okay, we can see that, I'll mark it right there, that's 0.9485. So I didn't mean to say but, okay, so here we can see that our correlation coefficient falls in the critical region, so we would conclude we would reject the null hypothesis, that rho, okay, equals 0. So that means that there is enough evidence to support the claim that there is a linear correlation between overhead width and weight of seals, okay? Now, if we use a significance level of 0.01, so at that significance level, let me use a different color here. I'll use, let's see, do I have purple as an option? I do not have purple as an option. So let me just use a color that I haven't used yet, orange, okay? So let's mark our critical value at that significance level. So 0.917 is about right here, okay? So 0.917 and -0.917. So I'll shade in the critical region at that significance level, okay? And then hopefully you guys can see that our correlation coefficient for our sample data, that 0.9485, still lies in the critical region, so it's still in the orange region at a significance level of 0.01. So we would still come up with the same conclusion, which is to reject the null hypothesis, okay? All right, so that's using the critical value method. Now, if we want to use the p-value method to make a conclusion about the null hypothesis, then let me write this down, okay? To use the p-value, we can write down, let me write down p-value method. We can use ln-reg t-test, and so from the ln-reg t-test, we see that our p-value is 0.0039. So at a significance level of 0.05, we can see that our p-value is still less than our significance level. So 0.0039 is less than 0.05, but 0.0039 is also less than 0.01. So we would come up with the same conclusion. We would still reject the null hypothesis, okay? So again, we can say that there is sufficient evidence to support the claim of a linear correlation. So now that we've done the hypothesis test and confirmed that these two variables, overhead width and weight of seals, right, really is linear, then this means that we can use the regression line. So we can use that regression line to make predictions. So this will give us predicted weight values. Okay, all right, so let's go back to the question here. Is there sufficient evidence to conclude that there is a linear correlation? All right, let me just write out the conclusion here. We would say there is sufficient evidence to support the claim Let me move this up so I have more space to write. To support the claim of a linear correlation between a seal's overhead width and weight. Okay, all right. I'm going to post below in the description links to other videos that cover the other examples in this handout, but specifically make sure that you watch the video on example 5 because it's a continuation of this problem on weighing seals with a camera. Show you what that looks like on your calculator. So when you go to LNREG t-test, make sure that for row here you choose not equal to 0. And then when you press calculate, it gives you all of this information for the hypothesis test. So you have your test statistic here, which is a t-value. Below that we have our p-value. And then this information down here, A and B, will give you the linear regression, and then go ahead and use the arrow key and arrow down, and that will give you the R-square value and the R value. So it gives you the correlation coefficient and the correlation of determination. Okay, so I'm going to go ahead and copy all that information down.